Welcome to Ask and Learn.
All right, guys, we're doing problem number 86 of chapter 5 in Chemistry Essential Science. So the nitrogen atoms in N2 are held together by a trope bond. Use enthalpies of formation in Appendix C to estimate the enthalpy of this bond. So we're going to do that. So remember the delta H of formation for element in standard state like N2 or H2, that's going to be 0. So remember Hess's law, delta H reaction is equal to delta H of products minus delta H of reactants. So delta H is going to be equal to 0 minus 2 times 472.7. So delta H is equal to minus 945.4 kilojoules per mole. Now, for part B, they said consider the reaction between hydrogen and hydrogen to produce ammonia. N2H4 plus H2 yields 2NH3. Use enthalpies of formation and bond enthalpies to estimate the enthalpy of nitrogen-nitrogen bond in N2H4. All right, so for consistency's sake, we're going to flip this equation so that we can show the formation of hydrogen with an NN bond. So first, we're going to find the delta H of formation. I remember delta H of H2, that's 0 because it's the element in standard state. Now we're going to plug this into our calculator. (187.78 kilojoules per mole). Now, we're going to estimate the strength of that NN bond. So we're going to set the delta H we have here as set it equal to Hess's law, but instead of using delta H formation, we're going to use delta H of H. We're going to use the bond enthalpy because the difference in the bond enthalpy from the products and reactants, that's roughly equivalent to the delta H of formation for the reaction. That means we're going to set it 187.78. Okay, what are our products? So we have for NH3, we have, let's put it as X for our NN interaction, and then we have 4 NH interactions. So 391. And then we're going to put it for H2, so 436. That's the HH bond. And then minus for our products, it's going to be 2 times 3 NH bonds, 391. So then we're going to add it all together. 4 times 391 plus 436 minus 2 times 3 times 391. Yes. And if we put that into our calculators, we are going to get, yes, we're going to get 187.78 is equal to x minus 346. So now we're going to add that together. So x is going to equal 533.78. So now that's kilojoules per mole. S. Now we can approximate it like this. So we're going to have this kind of reaction. 2N gas yields N gas, so we're assuming it's an NN bond. So we have our bond enthalpy 533.78 minus 2 times 472.7. So that's going to equal 411.62 kilojoules per mole. So we can see that this delta H is more positive than this delta H value. So so based on that, we can see that this is forming a triple bond is a more spontaneous reaction and more favorable reaction than forming just your double bond. So that means that our double. So to answer part C, if we look at the answers from A and B, we can see that the formation of a triple bond is more stable than formation of a double bond because it has a much more negative and of change in enthalpy, which is a more favorable reaction.